This is Satyan Bhatia, and we are here at the Open Source Summit in Vancouver. And today we have Animesh from IBM. Can you tell us a bit about what do you do at IBM?
Thanks for having me here. I work in the AI and machine learning part of IBM, essentially building the deep learning platform or the AI platform for IBM and building it with the support of the open source community. We definitely have a lot of technologies which we are trying to incubate with IBM Research, then taking it out in the open source community, as well as consuming things from the open source and building on top of it. Summarizing, building the AI and machine learning platform for IBM.
I'm also a science fiction writer, so I always look at artificial intelligence or AI. What is the difference between deep learning, machine learning, and AI?
For the most part, think of it like, artificial intelligence is the general branch, right? I mean, when the applications actually evolve and when they're deployed, do they have a notion of AI built into them, right? Now, how do you implement that AI? The implementation comes from the machine learning branch. Machine learning is something, which has been in practice now for decades. There was this AI winter, spring came, and now finally we are in AI summer. And 2012 is when deep learning came into existence. So from that perspective, you are looking at a relationship of, machine learning sort of spawning this specific field called deep learning, which is, around neural network models, how to craft them, how to architect them. In 2012, AlexNet came from Facebook. That was the first implementation of deep learning with GPUs that made deep learning popular. And then, the advent of GPUs from NVIDIA that essentially started democratizing and taking deep learning into, almost every data center where the power of a GPU can be harnessed. So these were the two drivers, and beyond that, there have been many advancements. The actual image recognition, which started in Facebook, that was, I would say, the first popular implementation of deep learning. Yeah.
And when you look at machine learning, deep learning, and AI, from IBM's perspective, do you look at them as a workload, or you are building framework to run those workloads, or you are building platform for deep learning itself?
So I would say, a lot of these words overlap, but definitely, a platform to run AI workloads would be the right way to characterize it. Right now, to build that platform, you use certain frameworks, certain technologies. Right. So, for example, the talk I'm giving tomorrow, where I'm talking about Fabric for deep learning, or as we call it, FIDDLE. Right. So that's something which originated in IBM Research. We actually, build on top of it, and it's essentially a platform to do distributed deep learning training on top of Kubernetes. Now, one of the reasons, why something like this is now becoming very popular in the industry is because the training part of deep learning is very, very computationally intensive, right? B, to actually make sure you are actually doing that instead of within weeks or months, in days, or even now, you want to do it in hours. You want to harness the power of an orchestration platform like Kubernetes, which can give you the scalability which you need, the computing power which you need, and then combine it with the innovations which are happening in the deep learning space itself, like the TensorFlow, which came out of the Google umbrella, PyTorch from Facebook. All these deep learning libraries have come, which have actually made creating these deep learning neural network models very easy. So combine them with the power of Kubernetes and the innovation happening now at the bottom layer of Kubernetes around consuming NVIDIA GPUs using the device drivers which came out of NVIDIA, combining some other innovations which are happening now on the data side of things in terms of making sure Kubernetes can act as a platform for data intensive pipelines as well. So a lot of these things are now coming together. So tomorrow's talk, essentially, we are talking about Fabric for deep learning. It's also in the open source. It's also powering our Watson Studio Deep Learning as a service, which is on public cloud. So you can actually essentially get it at github.com/IBM/FFDL. Yeah.
When we look at open source and when we look at things like Kubernetes or OpenStack or the Linux kernel itself, everything is fully open source. When we look at a machine learning space or deep learning space, how much of the component is open source?
No, that's a good question. So I think, so just within the context of IBM, right, there are different groups within IBM, like we have Power AI group, right? A lot of the innovation which our Power AI team is doing around deep learning or machine learning space is around, how to highly optimize the hardware so as to make sure, the deep learning workloads can execute much faster in a much more reliable manner. So a lot of the algorithms which are coming out of the Power AI umbrella, for a large part, they were proprietary because they were created with the notion of making sure, we can leverage the unique hardware characteristics of Power. Now, as we evolved, as we are moving forward, we realize that some of these algorithms or innovations which we have written, they can be used in a more generic purpose sense. So there is something which we had written, which we call the DDL, or distributed deep learning algorithm, which we used to, and we are still using internally within IBM, right? But very recently, we contributed a part of that to Uber's Horoward library for distributed deep learning. So Uber also has a mechanism to do distributed deep learning and a library dedicated for that purpose called Horoward. And we contributed some parts of our DDL algorithm to that, right? So I think a large part of that, ecosystem where how much is in the open source, how much is proprietary, also depends on, some of the things which these different companies and vendors are doing. Is this specific to the stack they are building, right? And over a period of time, when you do see that this can actually, not only benefit you by taking it out, it can also benefit others, right? Because now the general purpose usage has evolved to an extent where this can be used in a wide context. So then they start going out, right? So yeah, it's I would say that's how that landscape is evolving. For the most part, you see that over the course of last 1.5 years with the advent of TensorFlow, PyTorch, MXNet, Keras, now, the platforms coming in like Fiddle, which we have launched, Qflow, which coming out of Google. And then there are some other innovations happening like Hydrosphere, Seldon, which are on the model serving side. The whole ecosystem around open source machine learning platform is suddenly, spawning. And I think, this is going to get much more interesting. In some ways, this is like 3 years ago or 4 years ago, like cloud, when, there were different competing technologies in the open source vying for becoming that standard. There was this whole revolution around virtual machines with OpenStack, as you rightly mentioned. There was Cloud Foundry for the platform as a service. Docker had Docker Swarm. There was Mesos. And then Kubernetes came along, and right now what we are seeing is, for the most part, I would say 80% of the workloads are sort of, standardizing on Kubernetes, right? So we will probably see, 2 to 3 years down the line, something like that happening with AI. Right now, it's a very open landscape. A lot of competing technologies are coming and complementing technologies. And we are trying to, figure out which of them work together, which of them we can take to form a standard, where to take in terms of a foundation like Linux Foundation, and then, evolve that standard platform which can become like the Kubernetes of the AI world.
AI has been like, we have been talking for ages, but we have started developing technologies, So how do you see the evolution? What's coming next?
So what's coming next? I think that's a great question, right? So as you can see right now, there is a lot of focus around, the aspect of AI democratization, right? So essentially making sure that AI finally comes out from academia and research and gets mass adopted by AI developers and data scientists, right? So almost anyone in the AI community is right now very, very much focused on making sure, that mass adoption happens, that the set of skills which are needed, with the institutes like Coursera and Udemy and others, the tools which are needed, the platforms which are needed, they are being built on by the startups, by the enterprises, by the open source community in general. Now the whole notion of, if you look at it from a model perspective, which is the core construct of AI, right? Training a model, finally when you deploy a model, one thing the community is realizing, and in fact, the folks who have been doing it for long have realized that, these models are never perfect. Unlike, the applications which you build, which you can probably rely on, an enterprise application that, you can predict based on the inputs which it is getting, what sort of output it can give. The models are very fluid based on the data sets they have been trained on, or the subset of that data set. The behavior in production deployments is very different. The predictions are very different. The accuracy is falling. They can, give very biased results. So there is now, from a technology perspective, there is a lot of focus on okay, deploying the models is not the end. You need to have an ops platform which is continuously monitoring them, continuously monitoring it, not only for quantitative things like, the response time or the accuracy, but qualitative things like, are these models giving the unbiased answers? Are they, responding correctly? And if not, then how to make sure, we are pulling them in a continuous retraining loop, redeployment, whether we are pulling new data for that retraining, or we are using the same data but assigning different weights to those models to retrain, or we are doing bias detection in that data set, or we are launching some adversarial attacks to make sure these models are not vulnerable. So a lot of those discipline on that side. Now moving forward, there's a lot of focus happening around what we call the ethical AI or trusted AI, right? How to make sure the models which have been created, they can be trusted. Now there are so many different levels around that, right? So one is whether the models, the data set on which they have been trained, were these data sets unbiased to begin with? The second thing is, during the training phase, the weights which you are assigning to different parameters, are they coming from a biased individual human perspective? So that can be tested. The second thing is, once it is deployed, the bias testing can be done there. Then explainability. So for example, when you go to an insurance provider and an insurance claim is declined by an AI system, you want to know, the AI system, made the decision that I cannot get that insurance, but how? And what we are seeing currently in the current world, most of these model predictions are black boxes, right? You don't get an explanation as to how you came to that decision, how you predicted that, right? So a lot of focus on explainability in models, right? So as I said, on bias detection, explainability, doing adversarial checks, right? So if, for example, this field of adversarial libraries or adversarial robustness toolkits is becoming very popular, because what is happening is, if your image data set, for example, if you're training on images, is contaminated by 0.000 point, to the power of 5, even that much of contamination in your image data set, when your models are predicting results, those results are varying up to the result more than 90% in some cases, right? So that's where, there is a lot of research focus, academia focus, which has been around how to create adversarial attack methods, which you can then, launch on your models to figure out, whether, if the data sets are getting contaminated by a smallish percentage, how much variation they can give. And then if there are models which are found vulnerable, then how to actually implement some defense mechanisms. So a lot of work on that. So I would say, you would see the focus in the next generation of AI more towards, the trusted AI or ethical AI initiative, where, we want to make sure that, it's being done with the right data, with the right explanation why things are being done, and making sure, that we are not bringing any inherent bias either in the data sets, in the predictions, and as far as possible, AI is behaving ethically.
Thanks, Animesh, for talking to me today. And we'll, of course, keep an eye on the AI world, what is going on, and we'll keep talking about the progress that is going on and how this field expands. Thank you so much.
Sure. Thanks for having me, Swapnil, and hope you're enjoying the conference. Definitely, great energy here in Vancouver, and glad to meet you.
Thank you.